So in 10.3, we're going to talk about measures of position. So measures of position are benchmark positions that divide the data into more than two parts. So when we talk about quartiles, it says quartiles are three values that divide the data into four equal parts. So it kind of helps if we do something like this. So say you have two endpoints, and then you have some middles of the other two. Okay, so a quartile one would be that first section from where you start to here, and that would be 25% of the data here. This is quartile 2. It also represents 25% of the data. This is quartile 3. So those are four sections that are being divided, right? So that's why it says we have those three values that divide it into four equal parts. So you have one part here, one part here. Try to color code it so you can see the parts. Maybe that helps out a little bit. So those are like the parts of the data. So here's an example. So your first quartile, before I go to an example, actually, is like right here. It's kind of like you're dividing the data in half, and the quartile 1 is the midpoint between the actual half of all the data. So it's like the midpoint. Quartile 2 is just the midpoint of all the data, and quartile 3 would be like the second half, the upper half of the data being divided into two. That's what those quartiles are. Do you guys remember talking about quartiles before? Do you guys remember box and whisker plots? Stuff like that? That's kind of what this is. We do a little bit of it in this unit. Okay, so first we have some data, but you're going to want to make sure you put it in order. Put your data in order. But it looks like this is already in order. We got 30s, 60s, 70s, 80s, and 90s. So if it's not in order, you want to make sure you put it in order before you begin. And then we can kind of look here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we're dividing it into four groups, 16 divided by 4 means that there's going to be 4 numbers in each group. So you could put a line here, and then you could put a line here, or you could have thought, what's the middle? Put a line right between in the middle of those, and there's 4 here and 4 here. So that kind of helps divide that data into those 4 equal groups. So this spot right here would be like quartile 1, quartile 2, and quartile 3 is what that represents. So right here it says to find the median first. Trying to see, they do it a little bit differently in the way these notes were written than I've done before. So kind of going through it. So if we find the median first, that's actually quartile 2 that we're working with. So since it's an even amount of numbers, we just learned about median. There's not one single median number, right? So your median number would be like taking 77 plus 80, because those are the 2 middle numbers. So we're going to take 77 plus 80, and then we're going to divide it by 2. So 77 plus 80, when you do that in your calculator, and divided by 2 is 78.5. So quartile 2 would be 78.5. I might just scribble this out and bring quartile 3 here to have a little more room. And then when we go find quartile 1, it is like finding the average of these two numbers. Okay, the number before it and the number after it, finding its average. So 65 plus 69 and divide it by 2. So we would say 65 plus 69 is that, and divide it by 2 gives us 67. So quartile 1 will actually be the number 67. And then quartile 3 is these two numbers, finding the average of it. So it's like we're taking 88 plus 90 and dividing it by 2, which would be 89, right? But we can do it 88 plus 90 divided by 2, 89. So quartile 1 is 67, quartile 2 was 78.5, quartile 3 was 89. So we can do this to go draw a box and whisker plot like I just said. So to represent these numbers just kind of in a visual way, you're going to have a line, and we always represent the lowest and the highest number. So like 37 was the smallest number and 98 was the biggest number. And then it doesn't have to be perfect, but we know our middle number, which was our median, was 78.5. It's not really in this actual data values, but we found the average of that to be that middle number, which would be the median of the entire data set. And then, so this would be like your quartile 2 that you're representing. My quartile 1 number we found was 67, and my quartile 3 we found was 89. And then you just make a box there, and that's supposed to represent all the data values. So one thing about that is, if this was set up and each section was worth 25%, one thing that we can know is that from here to here, that's like 50% of the data that's happening right there in that box area. The whiskers are kind of like what are called outliers, numbers that can be maybe extremely low or extremely higher than most of the middle numbers. So 50% of the data will lie between our quartile 1 and our quartile 2. But when we talk about percentiles, it'll say percentiles are 99 values that divide into an equal 100 parts. So if you had a number line, you wanted to put 99 hash marks on it, there would be 100 sections though, because of how it would separate it. Just like when we did 3, there are actually 4 sections, so it's always one more than how many hash marks you have because you create those sections. Okay, so that's all percentiles are. It's not, I don't really know why they put that in there. But a percentile rank will be the percentile of scores that fall at or below a given score. So we're going to be talking about percentile rank and just a class percentile. Percentile rank and class rank is the word, actually. Good thing of the words. And they're two different things. So if we talk about percentile rank, it says like maybe you scored a 90% on the first statistics test. This was the 82nd percentile. So what this means, it says what percentage of scores are at or below yours. We don't really care about what your score was. We're looking at this when we answer it. We're saying that what percentage of scores are at or below yours would be 82% are at or below those scores. So basically only like 18% scored higher than you in this case. Okay. So a lot of times higher is better when we talk about percentile rank. That's a good thing to think. Higher is better when we talk about percentile rank. Like sometimes when we talk about birth weights, you know, I know none of you have probably had babies, but maybe you've been around people that have, or maybe you knew that your birth weight when you were born. Maybe you were really, really small and you knew that, and your family told you that you really only weighed like in the 10th percentile because you were so small. Or maybe you were a really big baby and you were in the 90th percentile. So what that would mean is if you were in the 90th percentile, only 10% of babies born were bigger than you. So you were a big baby, is what that would be. And I like to use that one because I had a baby only like 4 years ago. So, and it's something that like when I was born, I was very small. So I knew I was small because my mom said you were in like the 30th percentile. So I was really little. But maybe you don't think of it that way. Maybe think about scores or things like that. This one says, what percent of scores are above yours? I already answered that. So you take 100% and you would subtract your percentage, and that would tell you only 18% are above you. So again, just to kind of show that on a number line, like if this were 0%, and if this were 100%, I'm not going to do all the tick marks, but I'm going to say somewhere over here is about what 82% would be. So that can kind of show you that these people are below your score, 82 out of 100. And then these people are above your 82 over 100 score. When you think about, or I say score, out of your 90% score. So 82 out of 100 people would be below you. And then 82, the difference, 18, I wrote 82. 18, because this would be 18% from here to here, scored above you. So you kind of messed that up, sorry. Made a little mistake. Because these two numbers should add up to be 100%. What I was just trying to explain in a really awful way. Did you guys get that though? Do you understand that? So if you scored 82% or in the 82nd percentile, that means 82 or 82 of the 100, if there were 100 people testing, that's the easiest way to think of it, scored below you. If there were 100 people testing, that means 18 people scored above you. That's just subtracting. Okay. Felt like I had to say it again, even though you may have got it the first time. I messed up, so I wanted to go over it again. So now we're going to talk about finding the percentile rank. Basically, what percentage is below? Is maybe a question you could ask yourself. So we're going to do an example here, but it says what you're going to do is you're going to find the total in your class, and then you're going to subtract your class rank, whatever your class is, okay, whatever your ranking is. And then the answer from step 1, we're going to divide by the total amount. So whatever this answer is, we put that here to divide and get that amount. Then we're going to convert that to 100%. So whatever you get here, you would take times 100% to get that. So we'll go through an example like this one here. So it says Lisa's score was a 23. And this score was the 85th score from the top of a class of 240 scores. Calculate the percentile rank of Lisa's score. So we need to know how many total people were in this class. 240, because there are 240 scores, okay? So the first step would be taking the total amount and subtracting our rank, basically. We were the 85th score. We don't really care about Lisa's score in this case. That 23 is extra information. So we would just be subtracting, if they were the 85th score, we're trying to find out how many were below. So we subtract. So we say 155. Okay, so then we go to our second step. We take the answer from step 1. which was 155, and we divide it by the total amount in the class, or total scores that we had. So 240, so we have 155 divided by 240. Okay, so in your calculator, I'm gonna write like 4 digits out, 0.6458, and then you could do 3. I'll just put a repeating line, because that's basically what's happening. But if I want to turn that into a percentage, I take that 0.6458 that's in my calculator and take it times 100%. So times 100 gives me that. So they would give you rounding score, or not, they would not, sorry, give you rounding instructions, because when we talk about ranks, we will always round up to the whole number. No matter the rounding number here, we're gonna always round up if it isn't a whole number. So we would say the 65th percentile. So writing 65% is actually similar, because we changed it to a percentage, but in this section, because we're talking about rankings, they use the word percentile instead of a percent sign. Okay, so 65th percentile would be that percentile rank of Lisa's score. To find a class rank, which it says here, multiply your percentage value times the total in class. So if it's a decimal, we're always going to round down, in this case, to a whole number. So then we'll take total in class from our step 1 value and subtract it. Take your total class and subtract your step 1 value to get your class rank. So there's an example here that leads you through that. So Lee has received a percentile rank of 85% in the class of 50 students. What is Lee's rank in the class? So number 1 is we take that 85% times the total amount of people in class, so times 50. But remember, when we do this, we're really taking 0.85 times 50. Which is 42.5. But this one, we're always going to round down. So this one would be 42. Even though with general rounding rules, you'd round up, we're gonna round down for this one. Okay, always, always. Just the way the percentile rates work, they bump it down. It doesn't quite make that other number. Okay, so then our second step would then be to take however many were in the class, again, which would be 50. This is our total. You want to write total over it, you can. We're going to subtract our answer that we got, which was 42. So 50 minus 42 is 8. So 8 would be the class rank. So when we talk about class ranks, smaller is better. So like if you think about in your high school, I don't know if you're in a really big high school, it was probably really hard to be first in class. I think any high school, it's hard to be first in class anyways. But especially a really big high school with a lot of people to choose from. But like if you were first in class out of 240 people that you graduate with, that means you were the highest out of all those people. So when we talk about class ranks, smaller is better. Percentile ranks, bigger is better, and that's because we're thinking of it as a percent. We really want to get close to that 100%. So this kind of helps you go through working out finding percentile ranks or class ranks. And that's kind of the difference between the two concepts that you learn in this measure of position. So let's turn the page and go to application. We'll do a couple more problems, I think. Yep, just 2 more. So it says Tina ranks 65th out of 75 in her class. What is Tina's percentile rank? So this is when we do the 3 steps. This is when we're going to take our total and subtract our rank value. Okay, so how many were total in the class? Well, they said out of 75. So 75 minus 65 is 10. Remember, your second step would be to take that answer and divide it by the same total amount that you had. So 10 divided by 75 would be 10 divided by 75 would be 0.13, and it goes on and on and on and on forever. So you can write lots of 3s if you want, or put a line over it. That's really up to you. But remember, we're going to turn it into a percentage. So that's why I like to, you'll just probably leave that on your calculator. But if you're writing it down, maybe you would want to write, I would probably write 1, 3 with the line over the 3. Because that would be what my calculator's showing. I don't need to round anything yet. Okay. And then remember, your third step is taking that 0.13 on your calculator and taking it times 100% to turn it into a percentile rank, which would be 13.3, and it goes on and on. I think I said that wrong. The percentile rank has general rounding. The only one that's not general is the class rank, always rounds down. So this one would be 13th percentile. So back on this page, fixing my other mistake, we did round up on here, but it's not like you always have to round up. I kind of said that wrong because I was thinking about class rank, no matter what, you always round down. So maybe that word always will remind you that we will always round down. Here we're just rounding up because it's general rounding. Okay, and then the last one, it says James is ranked 80th in his class of 450. John, who is in the same class, has a percentile rank of 80. Who has the higher standing in the class? So here's the thing, we really can't compare them, right? So James, because they're 2 different ranking systems. And so they're not the same. You need to get them in the same type of ranking system to decide. So what's given with this information is that he is 80th percentile or class rank, sorry. No. He is 80th in his class, so 80th class rank, which is a percentile. I could have wrote the word percent, but we want to find the percentile ranking. So if he is 80th in his class, this is a class ranking. Remember, class ranking was smaller is better, right? So if we want to, we could turn it into percentile rank to compare to John. Let's leave some space. They told us John, who's in the same class, has a percentile rank. So what's given? Percentile rank of 80. So even though they're both 80, they mean 2 different things because class rank smaller is better. Percentile rank bigger is better. But they're both 80s, but they're 2 different rankings. So we really can't compare them. So we need to first turn them into the same thing. So if I thought, well, I'll turn that into percentile rank, I do my 3 steps for this one. I take how many total were in the class, 450, and I subtract his position, which was 80. And we get 370. My second step is to take 370 and divide it by 450. Which is 0.82, and the 2's repeating. So the third thing I do is turn that into a percentage by multiplying it times 100 in my calculator. which obviously would be 82.2 repeating. And so remember, we can always round this with general rounding rules. So this one would really be the 82nd percentile rank. So knowing that, I really don't have to go convert, John. If I just did this one, who's better? Percentile rank, which is better, bigger, or is it better to be bigger or smaller percentage rank?
Bigger.
Bigger, so we know James is better, basically, in this case. So we could say James, just from doing this, has a higher standing in class. Because that's what they were asking. Now, you could double check and put John just for practice and doing the other one. We could turn percentile rank into class rank. So here, I should probably write find percentile rank. So you're just going back and forth between the two ranking systems. This one was given percentile rank. We're going to find class rank. So class rank is when you take the percentage. So this is 80th percentile, which is like saying 80% times the total amount of people in class. So that's like saying 0.8 times 450. Which is 360. And then we go subtract the total amount. 450 minus 360, which is 90. So he would land as the 90th name in the list if we had all 450 names for this class. Whereas James, he landed as the 80th name, 10 people above him, right? So again, we prove again that James has a higher standing in class, in the class rank. Again, so you can compare it either way. Not if you were given this one problem, it's not like you have to do both of them and convert them, but maybe you feel more confident in one or the other for some reason. So you could go and convert John to class ranking if you prefer to do the class ranking over the percentile rank. Now, I have a lecture in the YouTube lecture list that were from old notes. So if you guys want extra practice, there are some more questions and I might explain it a little bit differently too. So if you want extra instruction on that, I'm going to put this up there in the YouTube playlist and it'll just say new notes. But if you want to see the old notes just for extra examples, because I think I have a few more than what's in this note packet, then you can go watch that on your own if you want. Okay. But what I've decided is, let me go ahead and stop recording.